Hi everyone, today I am going to go over phase changes, and I'm just going to go over the most important stuff. You can read some other stuff by looking at the notes. So I won't really talk too much about the solids or the liquids here, or gases, but know that gases can expand to fill an entire room. They can also be compressed. So gases are the only state of matter that can be easily compressed. Both liquids and gases are what we consider fluid because they're able to move freely. Okay. Gases have the most kinetic energy out of all the particles. So, gases exert pressure by colliding with each other and the sides of the container. So if you imagine a balloon that's filled up, what's going on is these gas particles are moving all about and they exert pressure when they collide with the walls of the container here. So that's really what's keeping the balloon inflated, is that you've got these gas particles constantly pushing or colliding against the container. And so pressure is defined as the amount of force over an area. Okay, so make sure you understand how gases exert pressure. There are 6 different phase changes that you ought to know. Melting and freezing, I think, are fairly obvious. You can imagine an ice cube. Same for evaporation. That's when you boil water or take a hot shower. And then condensation. We'll go over examples in a second, but we talked about the example of the steaming hot shower. Right, that causes liquid to form on your mirror in your bathroom. What you might not know is sublimation and deposition. So solid to gas and gas to solid, those are a lot more uncommon. Okay, so I want to go over some examples so that you can hopefully understand this a little better. So some examples, again, you should know melting, freezing, and evaporation. For condensation, morning dew, that's what we see here. You might notice water on the grass in the morning or on your car. We talked about the shower mirror. Yesterday you had an example of when you have an ice cold glass of water sitting out, you'll notice water forms on the outside of the glass. So these are all examples of condensation. For deposition, again, deposition is when you have gas becoming a solid. Snow or hail formation where it gets really cold is a good example of that. We'll see that iodine is also another example of that. You'll see in the video. And another example of sublimation is going to be dry ice. So dry ice is often used to keep things cold, like ice cream. And so dry ice is really just solid carbon dioxide becoming gaseous carbon dioxide. So solid to gas. Again, make sure you know all these key terms and all the different phase changes as well as examples. Check out my video here to see another example of sublimation and deposition. Alright, I wanted to show you a quick example of sublimation and deposition. Again, sublimation, that's a solid, as you can see here, these solid crystals, becoming a gas. Okay, so skipping that liquid phase. So let's take a look at iodine. That's what I have in this tube here. And it's going to sublimate here, solid to gas. So let's see. I'm going to heat it up with the Bunsen burner. Just kind of wave it in and out of this flame. And it doesn't take long for us to see that this really nice purple gas is forming from that solid. Okay, so when it cools down, it's going to deposit or become solid again, as you can see those sparkly bits. Okay, so this is an example of sublimation and deposition, the element iodine. When does boiling occur? So boiling occurs when the vapor pressure overcomes the atmospheric pressure. Okay, so I'm going to show you another video which will hopefully explain this a little better than I can. Make sure you understand this idea as well.
We know that boiling is strongly influenced by atmospheric pressure. pulled down by gravity, the air above us creates pressure, and that makes it difficult for bubbles to form and boiling to take place. We can think of atmospheric pressure as the collisions of air molecules against the surface of the water. That's the pressure. The more collisions, the greater the pressure. But water molecules can create pressure when they leave the liquid. As these faster moving water molecules escape, they collide with the molecules of air. This creates pressure, and we call it vapor pressure. In a way, the water molecules are pushing or colliding against the air molecules. This reduces the amount of pressure felt by the water. Back to boiling. Textbooks often state that when the vapor pressure equals the atmospheric pressure, boiling takes place. This is called the boiling point. Think of it this way. Atmospheric pressure pushes down, and that makes it difficult for the water molecules to spread out and form a bubble. But when the vapor pressure increases, molecules from the liquid escape, and they push against the air molecules and effectively reduce some of the pressure. This makes it easier for the liquid molecules to spread out, form a gas, and to rise to the surface. That's boiling. We can make boiling happen by either increasing the vapor pressure or decreasing the atmospheric pressure. Either way, once the vapor pressure and the atmospheric pressure are equal, we've reached the boiling point, and boiling can begin. One last thing. Different substances have different vapor pressures, and therefore they have different boiling points. This has to do with how strongly the molecules are attracted to each other in the liquid. The more strongly they're attracted, the less the vapor pressure, and it's more difficult to boil. Therefore, the higher the boiling point.
So we can make boiling happen by increasing the vapor pressure or decreasing the atmospheric pressure. We'll talk about these things in the future. You don't have to worry too much about it now. Next, I want to go over the heating curve. This one is the heating curve of water, but all heating curves will look similar. So you start off as a solid at negative 40 degrees down here. And so these lines are the three different phases. Okay? The flat lines are your phase changes. So at 0 degrees Celsius, we're going to get melting. If you're going the other way, then you would get freezing. So let's say you're cooling it down and you cool it down to 0 degrees, then your water would freeze. But for now, let's keep heating up our substance. So we heat it up to 0 degrees, it melts, and then from 0 to 100 degrees, it's in its liquid form, till it reaches 100 degrees Celsius. That's the boiling point of water. At 100 degrees Celsius, it's going to begin boiling. Notice here the temperature remains constant. So during that phase change, the temperature is actually constant. So boiling water will always be 100 degrees Celsius. It can't go hotter than that. And then after 100 degrees, if you get steam, it's going to be greater than 100 degrees Celsius. This is why steam burns. If you ever put your hand over like a rice cooker, that's why they hurt so much. It's because that steam is much hotter than just boiling water. Okay? So again, if you're going the opposite way, this is also the temperature in which condensation would occur. Again, make sure you're able to read a heating curve. Okay? This is the same thing. Lastly, we're going to look at pressure temperature diagrams, otherwise known as phase diagrams. So we're looking at this diagram on the right. And so a couple points. We have the triple point, where all three phases coexist. We've got the critical point here, where it becomes what we call a supercritical fluid, where these two phases become indistinguishable. That's at really high temperature and really high pressure. And then to find the melting point, you want to find the standard pressure. Remember, 1 atmosphere is our standard pressure. We're going to follow that line to see where a solid becomes a liquid. So at this point, it turns out to be 0 Celsius for water. If we want to find the boiling point, again, you follow that same line and you see where a liquid becomes a gas. And so here it would be 100 degrees Celsius. Okay, so make sure you're looking at 1 atmosphere if you want to find the melting point and the boiling point. All right, that's it for me. Hope you learned something new.